Now that we know how to identify some of the shortcuts for showing congruence, we're going to put that into practice in proving that two triangles are congruent to each other, starting with a given and ending with a statement that shows that the two triangles are congruent. So we're going to prove it a little bit more formally than we were doing in the last section. So we're going to revisit our strategies for proof that we introduced at the beginning of the year. Remember, we always start with what we're given. So in this case, we're given that ABD is congruent to angle BDC. So a good practice to put into place is when you have a picture and you have some given information, put that given information on the picture if it's not already there to help you organize your thoughts. So angle ABD is this angle up here. Remember, when we name an angle, the middle letter tells us where the vertex is, and the other two letters are points that are on the sides of the angle. So ABD. BDC is this angle here. And then we have ADB is an angle we want to mark it differently than the ones we've already marked because these aren't congruent to those ones. So ADB is congruent to DBC, that's this one here. So we do have two pairs of angles that are congruent. And before I write anything else, we're going to come up with a strategy of how we're going to show that the triangles are congruent. We're going to do it using the congruence shortcuts. So we think about the shortcuts that include two angles, so either the AAS or ASA, and we look to see are there any sides that we could show are congruent. And in fact, BD on this triangle is the same as DB on this triangle, right? They share that side. That would be the same in both triangles. And the property that says that something's congruent to itself is the reflexive property. So that's going to be our plan. Start with what we're given, state that these sides are congruent using the reflexive property, and then we'll have enough to say that the triangles are congruent using ASA. So let's show you what I mean. So angle ABD is congruent to angle BDC. That's given. Angle ADB is congruent to angle DBC, also given. And then the next thing that we talked about was this side being congruent to itself. So DB being congruent to itself. Now, I'm actually going to switch the order. The reason being that D, or the angle at D on this top triangle, angle ADB, is congruent to angle, notice how we worded it here, ADB goes with DBC. The D and the B are switched, so the D and the B will be switched when we write our sides. So DB is congruent to BD by the reflexive property. Reflexive. And now that we have two angles and the included side, the side that's between the two angles, notice angle, side, angle. So now we can say triangle ADB is congruent to triangle CBD. Notice the order. A goes with C, D goes with B, and B goes with D. And we know that because of ASA. ASA is our reason. Okay, so that's proved. We've proved that those triangles are congruent. With the given information and the other stuff we could show about these two triangles, we know that the triangles have to be congruent. Let's take a look at another one. So once again, we're going to start off with what we're given. Before we write anything down, we're going to come up with a plan for how to show these triangles are congruent. So AC, I'm sorry if that's a little bit blurry. Why is that not focusing? Okay, that's better. So AC bisects BD. So we have a little bit of vocab to revisit. Bisect means to cut it into two equal pieces. So here's AC. It splits BD into two congruent pieces. Okay, so what we write down, when we write down our given AC bisects BD, we're going to then be able to conclude that DO is congruent to BO. Right? We're going to be able to say that those are congruent. We can't just say that right off the bat. but we're going to be able to do that using that rationale there. And angle B is congruent to angle D. Angle B is congruent to angle D. Angle up there. So far we have an angle and a side, or a side and an angle. I don't think we have any way of showing that these sides are congruent, but we have intersecting lines. On intersecting lines, the angles across from each other, the vertical angles are congruent. So this angle is going to be congruent to this angle because those are vertical angles. And now we have an angle, a side, and an angle. ASA is enough information to know that these triangles are congruent. So that's our plan. We start off with what we're given, that AC bisects BD, and we're going to reproduce the thought process that went into putting our markings on there. So AC bisects BD. Before we go to our next given statement, so yes, that's given. Before we go to our next given statement, let's think about what we marked on our picture using the bisecting. So AC bisects DB meant that DO is congruent to BO. So that's what we're going to write next. That DO is congruent to BO, making sure that the corresponding parts go in the same order. Like O goes with O, D goes with B. And that wasn't given. That was because that's what bisect means. And whenever we use the meaning of a word to draw a conclusion, we are going to say that's its definition. The definition of bisect. Definition of bisect. And the next thing that we went on and did was talk about our other given statement, that angle B is congruent to angle D. That was given. And then the next thing that we wrote down was that third pair of angles, or that second pair of angles. Angle, and when we name this angle, we can't just call it angle O, because there's 4 different angles there we could be talking about. Angle DOA, angle DOA is congruent to angle, making sure to put the same ones in the same order. D corresponds with B, so angle BOC. So DOA is congruent to BOC because those are vertical angles. Vertical angles. There was the vertical angle congruence theorem that we used back when we talked about angle pairs. And then finally, now that we have stated explicitly that we have a congruent side, we have congruent angles, we have another pair of congruent angles, and the side is between the two angles, so that is ASA for our reason. ASA, we can say what we were trying to prove all along. Triangle DAO is congruent to triangle BCO by the ASA congruence theorem. Okay? Let's look at another way to express the same idea. So another way to express this proof is in a flowchart format. You know, when you're planning to write something, or if you're trying to express the flow of a story, you might describe things using the flowchart. All these things are leading up to some other point. So we're going to use a flowchart to prove that triangle ABD is congruent to triangle CBD. Now the thought process remains the same. This is just a different way to organize our thoughts. So we have that AB is congruent to CB. AB congruent to CB, and that's marked on there for us. So we could start there. AB is congruent to CB, and our reason is that it's given. So we include, unlike our 2-column proof, we include the statement and the reason in the same bubble. Okay, so we have AB is congruent to CB because that's given. The next thing, D is the midpoint of AC. D is the midpoint of AC. So looking at the diagram, D, if it's the midpoint of AC, that would mean that AD and CD are the same length. So notice how that given statement brought us to a conclusion about those segments. So this is where this intermediate flow part comes in. So D is the midpoint. D is the midpoint of AC is given. But that led us to the point that AD is congruent to CD. CD. Now I am kind of getting ahead of myself a little bit. I said to come up with a plan before we start. So before we, well, actually, let's just continue our thought here. So D is the midpoint of AC, was given. That led us to believe that AD is congruent to CD, and that's because that's what a midpoint is. That's our definition. Just like we had said with the definition of bisect, this is the definition of midpoint. So we have a pair of sides, another pair of sides, and then we need one more thing here. And we could go a couple different routes. Probably the most straightforward way is to say that DB is congruent to itself. So we have three sets of sides that are congruent. So we say DB is congruent to, and in this case, DB is the right order to have that in. It's the D corresponds with D and B corresponds with B in our triangle. So DB is congruent to DB. The reason we say it's congruent to DB is we're talking about DB in this triangle as one of the sides. We're also talking about DB in this triangle as one of the sides. And all we're identifying here is that it's the same DB. Something is congruent to itself by the reflexive property. So we do, when we're talking about using our congruent shortcuts, we have to have the three things stated explicitly before we can draw our conclusion. So we have a side, and another side. That is going to be the SSS congruence postulate. So triangle ABD is congruent to triangle CBD by SSS. Okay, so we have our statement and our conclusion. This is a flow of our progression of our thoughts. Okay? This was given. That is part of our conclusion. We're only able to say SSS because that's one of our S's. And this is one of our other S's. And this is one of our other S's. So we have our three arrows pointing into our conclusion. We can only draw that conclusion because of those three trains of thought. And then finally, we're going to do one more example. And this one, I think I'm going to go back to, well, actually we've already done two column ones. Maybe I'll do another flow proof. So this one I'll draw the flow proof. I'll do it vertically instead of horizontally like this last one, just to show another format of how we can organize our thoughts. So first, let's look at the diagram. Let's make sense of it. Let's come up with a plan for how we're going to show that the triangles are congruent. So segment AB is parallel to segment CD. That's already marked on the diagram for us. The arrows mean parallel. And segment AB is congruent to segment CD. That's also on the diagram, the dash markings there. But so that congruence marking is probably going to be part of our conclusion, like one of the arrows that's pointing in our conclusion, because we need S's and A's, right? So this is probably going to be one of our S's. Let's see what else we can conclude from the parallel lines, though. So there must be some reason why they're telling us this. These are parallel. Well, when we talked about parallel lines, any segment or line that connects the parallel lines together, that intersects both of them, forms angles with those parallel lines. And we know something about the angle pairs on parallel lines from a previous unit. Notice CB forms an angle with AB. It also forms an angle with CD. This angle here and this angle here are on opposite sides of that transversal and are between the parallel lines. Those are alternate interior angles. So we have a pair of angles that are congruent. These two triangles also share a side. They share CB or BC. So knowing that, we have a side, an angle, and a side. So using our flow proof strategy here, if I said that AB is parallel to CD, well, that's given. That's one of my bubbles. And that led us to the fact that angle ABC, is congruent to angle DCB. Those angles are congruent. And our reason was those are alternate interior angles. Alternate interior angles. So So that's our next bubble. That's going to be one of the 3 arrows. Oops, sorry, we're getting below our picture here. That's going to be one of our 3 arrows pointing into our conclusion. So we're all trying to lead up to this triangle ABC is congruent to triangle DCB. We're trying to lead up to this. This is going to be one of the things that leads us to that. And the next thing that we said, AB is congruent to CD. That was one of the sides we included. That was given. And this, there's no intermediate step. This is just part of our, or when we say that the triangles are congruent, we needed a side to be congruent. We needed an angle to be congruent. So we have an angle, we have a side. We just need to state that last side there, CB. So CB is congruent to, and before we say CB or BC, let's check the order. B corresponds with C, C corresponds with B, so we got to switch the order. BC. So CB corresponds with BC, or is congruent to BC. Not that that was given, that was not given to us, but that's because of the reflexive property. Something's congruent to itself. Reflexive. And that leads us to our conclusion. So we have a side, we have an angle, and we have another side. The angle is the included angle. It's between the 2 sides. So these are congruent by SAS. Okay? So one nice thing about the bubble with a flow proof is we have these, we can see clearly where the S, the A, and the S come from. So there's our 2 S's, there's our A, and based on the diagram we can tell that the A is between the 2 S's. Okay? So we're going to do some more practice with that in the coming days and add on to that in TC7 with drawing additional conclusions from congruent triangles. But we'll practice those proofs together in class. I'll see you then. Bye for now.